Alright guys, welcome to this page of the notes, and what we're going to do is just do a few more problems here where we're really going to kind of drive home the theorems about parallelograms, and that theorem gives us the relationship between the sides, angles, and diagonals of a parallelogram. You need to know those relationships really well, right? So that the opposite sides of a parallelogram are congruent and parallel. You need to know that the opposite angles of a parallelogram are congruent, and you need to know that the diagonals of a parallelogram bisect one another, right? Those are our relationships. So let's go ahead and take a look at a couple more problems here. What I'm asking you here in this first one is, what do you need to know first in order to apply the theorems we've learned here in this set of videos and this section of notes? Well, we're talking about quadrilaterals, four-sided figures. But the theorems we just talked about only apply to parallelograms. So what you would need to know is you need to know that got weird. You need to know if the quadrilateral is a parallelogram. If the quadrilateral is not a parallelogram, none of the theorems we just talked about apply. They don't apply. But if the quadrilateral is a parallelogram, then you can apply all of the theorems that we just used. Opposite sides are congruent and parallel. Opposite angles are congruent. The diagonals bisect each other. All of that only applies if the quadrilateral is a parallelogram. So really important. I either have to tell you that it's a parallelogram, or based on the information that I give you, you must determine that the quadrilateral is a parallelogram. If it's not a parallelogram, you cannot apply any of the theorems that we've just talked about. All right, really important idea. Finally, the next question here is this is all about our essential question. Remember, the essential question was, what are the relationships between the opposite sides, the angles, and the diagonals of a parallelogram? That was our essential question. That's what we started off this set of notes asking, this set of videos asking was the question. So here we go. I want you to name all of the congruent segments, angles, in the figure below. So right here, I've given you a parallelogram. I tell you it's a parallelogram, so here we go. First, let's start with the sides. Okay, well, what do we know about sides? Well, I know opposite sides are parallel and congruent. So I know that side JK is congruent to side ML. I know that side JM is congruent to side KL. I know that opposite sides are congruent. I also know that opposite sides are parallel, right? Parallel and congruent. But I only ask you to write congruent statements, right? Congruent segments. So you don't have to tell me they're parallel. I just asked you if they are congruent or not. In addition to sides, excuse me, I also know something about the diagonals. Right, what do I know about diagonals? Well, I know that the diagonals bisect each other. So I know that JN is congruent to LN, and I know that KN is congruent to MN. Right, I know that JN and LN are congruent because that diagonal is bisected by the other diagonal. Vice versa, I know that KN is congruent to MN because KM is bisected by the other diagonal. So diagonals bisect each other in a parallelogram. So that takes care of the congruent segments. Now, what about angles? We've got a bunch. First, let's start with the opposite angle. So for a moment, ignore the diagonals. Let's just talk about opposite angles. So angle J and angle L would be congruent. Angle J is congruent to angle L. And angle K would be congruent to angle M. Right? So those are my opposite angles, but we went even further than that. Once I add the diagonals, then I can use those angle relationships from chapter 4, parallel lines cut by a transversal, right, to then find other angle relationships, right? So remember we said same side interior angles are congruent. So I know that this guy right here is congruent to that guy, right? I know that those are congruent. Let's see, what else do I know? I know that those guys are congruent. I know that those guys are congruent. And I know that that guy and that guy are congruent, right? So those are going to be based on the alternate interior angle theorem, which comes from chapter 4, parallel lines cut by a transversal. So we can go ahead and write all of those. This will just take a second. I know that angle K... Oh, I'm sorry. I accidentally switched back to that previous page for a second. Here we go. I know that angle KJN is congruent to angle KLN. I know that angle, let's see here, let's do MJN is congruent to hang on, I messed that one up. Wait. I know that angle KJN is congruent to MLN. There we go. And that angle MJN is congruent to KLN, the yellow hash mark. So L, KLN. There we go. All right, got those. So these are the green ones. In fact, I should have done them in those colors. So KJN. There we go. I absolutely should color coordinate these. That's why I got these colors. Hopefully that'll help you see those relationships. So these are the green ones, right? Those are alternate interior angles. The yellow ones, alternate interior angles. Let's do the red ones. I know that angle JKN is going to be congruent to angle LMN. And finally, the blue ones, I know that angle JMN would be congruent to angle LKN. I apologize, I had to squeeze on that one. So that takes care of all of those. The green, the yellow, the red, and the blue, my alternate interior angles. And then finally, last ones, we talked about vertical angles, right? The diagonals create two pairs of vertical angles right in the middle of the parallelogram. So let's write both of those. These are going to be my vertical angles. Thanks to vertical angles, I know J and K. So J and K is congruent to M and L. So J and K and M and L, those are vertical angles. They have to be congruent. And then vice versa, the other set, J and M. So J and M has to be congruent to K and L. All right, so a gigantic list, but that's all of them. We got all of our sides as well as this diagonal segments because the diagonals are bisected, and then all of our angles. Opposite angles of the parallelogram are congruent, but then there's all of these angle relationships thanks to alternate interior angle theorem and the vertical angle theorem. Lots of angle relationships inside of a parallelogram, all of which you'll need to know, you'll need to remember, you'll need to be able to find, because I will ask you questions about them where you can set up those algebraic expressions that you can then solve to find an unknown measure or length or something like that. All right. I got one more question for us here just to sort of wrap things up. So let's take a look at this last one. What I've done is I've given you a parallelogram. I tell you it's a parallelogram. And I tell you that point P lies on DC. So there it is, point P, as shown in the figure. Here's what I want you to do. I want you to explain to me why it must be true. I'm telling you it is true that DC is 2 times AD. DC is 2 times AD. So I want you to explain to me, based on the fact that this is a parallelogram and the information I've given you, why must it be true that DC is twice as long as AD? Awesome. Here we go. Okay, so this is going to take us back, as we have seen in every chapter, to previous information. And we're going to take all of that stuff we've already learned, right? All that geometry, all those theorems, all those postulates, we're going to bring them here into this chapter and use them to help us answer this question. So here we go. First, the new information. I know that AD and BC are parallel and, more importantly, congruent. So I know that AD is congruent to BC, right? How do I know that? Well, because it's a parallelogram and opposite sides have to be congruent. So I'll go ahead and erase those red marks and I'm just simply going to put in these little hashes, right? I know that those guys are congruent. They have to be. It's a parallelogram. Now, once again, seeing this idea yet again, guys, remember, opposite sides of a parallelogram are parallel, which means we have that alternate interior angle theorem, which says this. I know, thanks to the alternate interior angle theorem, that this angle and this angle are congruent. This angle and that angle are congruent. How do I know that? Well, because, right, these lines are parallel, and I have 2 transversals. I have this transversal right here in yellow, and this transversal right here in green, right? Think of them separately. Parallel lines cut by a transversal, opposite alternate interior angles are congruent. We know that. Same thing here. Parallel lines cut by a transversal, alternate interior angles must be congruent. What does that mean? Well, check this out. Let me go ahead and erase all that stuff that I just put in there. Since they're alternate interior angles, here's what I now know. If that angle is x, the alternate interior angle must also be x. So I know that that is x. Alternate interior angle. If this one's y, this one must also be y. Alternate interior angle. So that one is y. Now, what that means for me is this. Look at this. Angle x, angle x. Those both have the exact same measure. So now we're going to go back to a previous chapter on triangles with isosceles. Guys, remember isosceles triangles? Remember, isosceles triangles are any triangle where the base angles are equal. And that's exactly what I have. I have 2 base angles in a triangle that are equal. Now the theorem with the isosceles triangles was if the base angles are equal, then the sides opposite those base angles are also congruent. What that means is that the side opposite this angle x, which is dp, must be congruent to the side opposite this angle x, which is AD. That just simply means, thanks to isosceles triangles, that side AD is congruent to side DP. Isosceles triangles, absolutely, I keep saying it over and over again, all of that information we've already talked about, theorems, postulates from previous chapters, you still need to know that stuff, right? And we'll refresh, we'll go over it as we move through the chapters, right? That's why we do these example problems together, right? Just to sort of refresh your memory on those previous theorems and stuff, but absolutely isosceles triangles will come back in this chapter. Here's an example of it right here. Here's another one. Angle Y, angle Y. The base angles are congruent, which means the sides opposite the base angles are congruent. So that means that side BC is congruent, right? This side BC has to be congruent to side PC. Well, now I have everything I know. Look, check it out. All of those red hash marks mean each of those sides is congruent. So what I've got here is this very, very simple idea. I said DC is twice as long as side AD. So the last idea here is simply this. Side AD is congruent to side DP, which I have right here. AD is congruent to DP. But because AD is congruent to BC, right here, and BC is congruent to PC, by the transitive property, PC must also be congruent to AD. Right? All of these sides are congruent to each other. Since each of these sides are congruent to each other, right? DP plus PC, right, would be twice as long as AD, and so we have our theorem, or the statement that I asked you to prove is true. We have just shown, thanks to, right, this congruence, that DC is twice as long as AD. Right? If this is side AD, right, you'd multiply it by 2 to find the length DC, since AD and DP and PC are all congruent. They're all the same length. And we got that, again, based on what we know about parallelograms, the theorems we just talked about in this section, and going back to alternate interior angle theorem, previous chapter, going back to isosceles triangles, previous chapter. Absolutely, you gotta know all of that previous information. You'll see it come up in problems. All right, guys, thanks so much for joining me for this set of videos. In the next set of videos, we'll continue our discussion on parallelograms. I can't wait to see you there.